Hello everyone, I'm Tushar Nagarajan and this is our work on step differences in instructional video. Video understanding approaches today typically process a single video and can describe details or answer questions about objects and actions, for example, what's a person doing or what tools is he using. And this has been the standard treatment in multimodal language models that's shown some fairly impressive capabilities recently. But this is only one part of video understanding. We humans have the ability to browse collections of videos and reason across all of them in parallel. In this setting, a new class of questions emerges as critical for video understanding. For example, what's the main difference in technique here, or did I make a mistake compared to this reference videos? Underlying these questions is the fundamental requirement for models to perform this comparative reasoning that's missing in today's models. Our goal of this work is to train such models that could lead to several applications that require fine-grained understanding of collections of videos rather than a single video at a time. For this, we propose StepDiff, a framework to train models that describe similarities and differences between video. We do this in 3 stages. First, we convert instructional video datasets into training data. We select segments from different videos that show the same key step, for example, a step in a recipe, but that naturally have differences in their execution. Next, for each segment, we use a series of off-the-shelf captioning and object detection models to generate text descriptions of the video, and then use an LLM to aggregate this information into a step description. Finally, we prompt an LLM to compare and contrast the generated text descriptions to generate a sequence of questions and answers that involve reasoning about both videos together. This paired video QA data becomes the training data for our models. This is automatically generated and it's naturally noisy, but it captures this new class of comparative reasoning questions spanning various relevant axes like tools, ingredients, consistencies of mixtures, and so on. We use this data as weak supervision for training. We do this using visual instruction tuning of multimodal LLMs. This works by converting each of our videos into a series of features or tokens using a video encoder and then a trainable projection layer. These tokens are then fed into a large language model along with a text specifying which video is which, along with a relevant question in an interleaved fashion. The model is then trained to predict answer tokens conditioned on the question and both the videos. Once trained, the model can then take 2 videos and a question and generate the answer as usual, or generate the log likelihood of any particular answer given the pair of videos. Finally, we evaluate our model on our StepDiff benchmark. Compared to the training data, which is automatically generated and potentially noisy, we manually collect clean data for a high-quality test set. The data contains pairs of videos with fine-grained difference captions across 5 categories: ingredients, tools, techniques, actions, and visuals. It also comes with a score for how severe the difference is, where 1 means very different and 5 means very similar or nearly identical. In total, we collect roughly 36,000 difference captions of this kind, and we use this to evaluate our models. We evaluate on 3 key tasks. For captioning, given 2 videos, the model must generate the main difference in a specific category, as shown on the right. For recognition, given a difference text, models must select which pair of videos from a set of options best captures the difference. This is done by calculating the generation probability of the difference text for each pair of videos and then selecting the most likely one. Finally, for ranking, the model must rank videos based on how severe the difference is compared to a common reference video. This is done by asking, do the 2 videos show the same tools, for example, and then selecting the video candidate with the most confidence response text. We compare against several classes of models: vision language embedding models that just match text to videos, Socratic models that perform text-only reasoning on top of step captions from various other models, and multimodal LLMs that are trained with either single videos or interleaved videos for captioning tasks. Our approach outperforms these on all of our benchmark tasks across all baselines. Here is a qualitative example that highlights how Socratic models fall short when text descriptions themselves are incomplete, and how VCLMs have a tough time distinguishing the visual content of the two videos, and instead treats it all as a single video and answers questions based on that. Finally, we show how our models, now equipped with the ability to compare and contrast videos, can be prompted to perform higher order reasoning beyond the difference identification it was trained for in the first row. These include comparative reasoning about the amount of carrots added into the pot in the second row, identifying the mistake that the person may have made compared to a reference in the top row here, and picking out which of the two recipes are healthier or messier or any other qualitative aspect of them that requires comparison in the bottom row here. To summarize, we introduce a framework to unlock comparative reasoning with multiple videos over multimodal LLMs and evaluate their capabilities on manually curated step difference benchmark. Please visit our project page and stop by our poster session for more details. Thank you.